Perth Linux Users Group, talking Linux and open source.
I'll give you an intro. So, ladies and gentlemen, welcome to Plug. My name is James Bromberger, and I'm now not the Plug president, but I'm standing in since Ewan's not here tonight. Tonight's speaker, Adrian Woodley, works for Motorola. Is someone who I've known for 15 years, give or take. Adrian was involved with the LCA 2003, way back in the day. By day, Adrian now works, as I said, for Motorola, hacking RF networks. And marrying that to IP. And tonight's talk is on IPv6. Please make him feel welcome.
Yeah, as James said, this will be on IPv6 and how you can get it at home on your very own. My name is Adrian Woodley. I work for Motorola, building radio networks for the police. Yes, I have a police radio in my car. No, you may not have encryption keys. That way around. Okay, so why IPv6? IPv4 uses a 32-bit address space. You guys are probably familiar with it. You're 4 octets, 8 bits each, 32 bits. That gives us, come on mouse. No, it's not going to do it for me. What are you doing? Oh, there we go. About 4 billion addresses, or 28.8 addresses per square kilometre on the surface of the Earth. Not a lot. We're running out. Everyone knows that. Okay. I think I've got it sussed. IPv6 uses 128-bit address space, much bigger. No, don't have it worked out at all. This is why you shouldn't use impress, because it's far from impressive. Come on. Okay, get rid of that. Oh, we can have a crack. It's Lenovo, it should work fine. It's even got a laser pointer.
It does have a laser pointer.
And it goes backwards and forwards. Okay, we're rocking.
Check the laser pointer. Check the laser pointer. Ooh.
You're not going to be able to chase cats with that. Okay, so we get a lot of addresses per square metre on the surface of the Earth. It's all fantastic. Everybody's seen these stats before. Nothing new. So why IPv6? Again, we're running out of addresses. 28.8 per square kilometre sounds like a lot. When you take out the private IP space and multicast and all the ridiculous addresses that Ford and IBM have, we're running out. In the Asia Pacific region, we've already run out. China is just a massive NAT behind NAT behind NAT. It's a bit of an issue. IPv4, because of the scarcity, to make best use of the available address space, we've had to carve the subnets smaller and smaller, which has made the routing tables bigger and bigger. Means you need more memory on your routers. It's much more complex to process routing tables. So if you have, when you're sorting out your BGP tables and that sort of thing, much more processing power needed, much more memory. It's all very messy. IPv6 has a limit of just over 8,000 subnets in the routing table. Because of the way, you only ever allocate a /64, makes it a lot tidier, removes a lot of the issues. It's got a simplified packet header, probably doesn't really matter that much. IPv4 works okay, IPv6 works just as well. It is optimized a little bit for embedded hardware, so the routers don't have to work as hard when they're doing their routing, but I don't know, CPU cycles are cheap, who cares? You get auto configuration. We have good auto configuration at the moment, right? DHCP works beautifully. If you've got your network set up, your home router will do it. Decently set up Linux server. Even Windows can do a DHCP and DNS really well. IPv6 does it without any of that sort of stuff. So you have your router and you get an address and you're away. That's all you need. The asterisk is you don't get DNS for free, you don't get a whole heap of other stuff for free, and it gets really, really messy to set that up and painful. So yes, we get auto configuration, but there's caveats. So why not IPv6? Bootstrapping refers to the fact that it's taken a long time for us to get websites and services on IPv6. That's because we haven't had the user space on IPv6. We haven't had the user space because we haven't had websites. No one was really willing to budge. That's all changed now because of World IPv6 Day last year and the previous trial the year before. We now have a lot more websites and services available on v6. We're starting to see more users come up. That's only going to grow, particularly as the expense of IPv4 goes up because of scarcity. Less of an issue. I know the US government are pushing v6 in a big way. I think all equipment that's sold to the US government now has to be v6 compliant. Speaks for itself, really. No one can remember all, whatever it is, 128 bits, whatever, how many, what do we call them? We don't call them octets. They call them the bit between the colons. There was a bit of a debate as to what to call them. Numbers, yeah. Like I said, hardware and software support is changing. What are you after, Nick?
No, he's trying to drink a white shot.
Most devices that are coming out these days have reasonable v6 support. You know, all your current operating system, Linux has had it since forever. Windows XP and beyond has it. My phone has it. It's coming. Again, with Linux, most applications will support it reasonably well because it's built into the lower level libraries, and if they can use TCP or UDP or whatever, it'll work reasonably well for v6 and v4. No real problem. Or you're just lazy. Okay, the big one for v4 is NAT. Okay, this is the main reason why you would change away from v4 to v6. Aside from address scarcity and that sort of thing, NAT is the bugbear of my existence. It gets in the way. If you're trying to do VoIP or, I don't know, all sorts of things where you have two private networks and the internet in between, it's a hassle. The reason we have things like VPNs is because private IP space, internet in the middle, and you want to be able to, you want the two to be able to talk without the rest of the world to be able to see it. So you don't buy public IP space. It's all really messy. There's all sorts of neat little tricks to get around it. IPv6 gets rid of all of that. If you have two networks which you want to talk together in a secure fashion, you use IPsec and they just route. All just works. You don't need VPNs. If you have two VoIP phones that you want to be able to talk together and they need to be able to negotiate an RTP stream, it just works. They can just talk to each other. There's no punching holes in NAT or anything like that. An excellent reason to move on. Oh yeah, I came up with this analogy that NAT is sort of like your corporate account manager for a big company. So you grew up with a guy, you went to uni together. If you want to go have a beer with him, you ring him up and say, let's go have a beer. You go have a beer. You graduate uni, you both get jobs at large corporate entities, and suddenly between you and him, there's now an account manager. So if you want to ring him up and ask for how do I set up this router, you can't ring him up straight away. You've got to talk. Probably you'll have to talk to your account manager, who will talk to their account manager, talk to him. It's all really messy. v6 makes it flat. It worked well when I was doing the dishes last night. Thought of that analogy. I don't know if it really translated. As I said, there's more websites that are available on v6. These are the top 5. And Akamai, which is a content farm. Most stuff's on Akamai, YouTube, everything. It's all on Akamai. But yeah, that really covers off sort of your, 90% of your internet traffic on those two. And it works on v6. You don't need, there's no v4 requirement at all anymore to access these. So really, there's no need to have IPv4. You can look at pictures of cats and search stuff, and that's fine. Okay. So now I've got you really excited about getting a v6 account or a v6 connection. Here's how we do it. The best way is you get yourself an Internode account, you get one of their routers. It's beautiful. We could all go home now. IONET is playing around with 6ID. I don't like this as much. It's a bit of a nasty hack, and it's because they're lazy. But it works okay. There's a couple of issues with it. Or you can get a tunnel. IONET do quite a good one for non-production traffic. IPv6 Now is an Australian company. They do tunnels for production stuff, large-scale networks, that sort of thing. Can be quite expensive. And there's a couple of free ones that you can pick up as well. But they tend to be hosted in Europe and the US. So, you know, even if you're looking at a v6 page in Australia, you're still going via the States and back your head. So really, top one's your best option. Internode, the only one I'm aware of in Australia who are doing v6 over PPPoE or over PPP in general. Probably IONET will go the same way now that they've absorbed them and bought all their intellectual property. There hasn't been any word from them though, so at the moment 6RD is your best bet there. And then we have the last one. This is horrible. It works, everyone can use it. The routing's really nasty. It's actually pretty similar to 6RD, but 6RD has local support. 6-4 uses what's called an Anycast router. Could be anywhere on the internet. Again, you could be going via the States or Europe or wherever. So yes, you can use it. Would I recommend it? No.
What's the difference between 6RD and 64?
Well, I was going to cover it later, but I can cover it now. Okay, so the question was, what's the difference between 6RD and 6-4? And yeah, I'll cover it when I have diagrams and stuff. So IPv6 over PPP. This is your very basic diagram of how you get to the internet. There's your home router, DSLAM, BRAS. That's where your PPP session terminates. That is generally, you know, the ISP's network, and you're onto the internet. And, you know, okay, I've got different colours. So green is v6, blue is PPP. Obviously, we drop off our PPP sessions here, and we're just straight native IPv6. It's all very simple and straightforward, and everything works beautifully. It's what your network stack looks like. So we have our TCP, UDP applications happening up here, IP packets, PPP packets, Ethernet. Very straightforward. And your byte sizes.
What's the BBA BRAS?
That's where your PPP session, broadband aggregator, BRAS, something. Yeah, yeah. Everyone uses these now, not these. I don't know. They probably called something. This is all. I picked all this up when I was working at IONET. They probably bought something else by now. But it's, yeah, your PPP session terminates there. Very simple process. You know, you establish a PPP session with the BRAS or the BBA. Your router will do a DHCP request for the prefix for its network. I'm not too sure why they chose DHCP. Seems to work quite well. The router will then take that prefix, give itself an address out of that prefix, and advertise it to the rest of your network, and you're on your way. If you buy a packaged, you know, something like the Internode Fritzbox or something similar that supports v6 out of the box, it all does all that automatically. You just plug it in and it just works. Getting Linux to do it is a little bit trickier, not too bad. You need PPPD, obviously. Program called Wide DHCP v6 client, packaged for Debian, packaged for everything.
Does that mean that it will do that every time the router boots up, so it's a different address each time?
The question was, will you get a new address every time you connect? Yes and no. It depends on what the ISP chooses to do. So you would hope that they'll give you a static prefix and you'll get the same address every time, and you know, it all works really well. That's what I have at home with Internode. There's no guarantee that if another ISP implements it, they won't choose to give you a dynamic prefix and charge you to have a static one. It's all up to how nice they feel and whether they think they can make money out of it.
You're talking about the internal subnet that you would have of IPv6 on premise, which would mean that every time you reconnect, every device in your house would have to re-request a new address.
Which happens with other things like 6RD and 624.
What a pain.
Yes, yes, but
I mean,
ISPs aren't always our friends,
that's true,
right?
but you couldn't imagine that now with NAT, using 192.168.1/24, having to restart or re-IP internally just because the DSL modem is reconnected.
It's not as bad as it sounds by a little bit, in that it's only the prefix that changes. Your actual address stays, everything...
Right, based on your MAC address, the last
Correct. So
yeah.
that would all be consistent. But you're right, everything would have to get a new address,
at that time.
update DNS records and all that sort of thing. You could, yeah, that would work.
Yeah,
Yes.
that's true. That's true.
Yeah. I haven't had a lot of success with link local stuff. And it's sort of okay if you've got two laptops and you plug them together, and anything more than that, it just doesn't seem to be as usable as something like, you know, v4 local addresses.
Yeah.
As I said, with Internode, I get a static prefix. It all just works. Given they're the only ones in Australia doing it at the moment, it's reasonable to assume that other people will also supply static prefixes, but it's not a guaranteed thing. This guy here, RADVD, that's the one that advertises the prefix to the rest of your network. And it can also tell you other useful stuff like the IP address of your DNS server and what your domain name. It's sort of like DHCP, but it's stateless. So instead of a request coming into the DHCP server, it allocates your address, tells you everything, and records the fact that it's allocated that address and doesn't give it to anybody else. RADVD just broadcasts this stuff onto your network. And when you want to connect, your machine will wait for the broadcast, pick up the prefix, pick up the DNS server and everything else, and sort its own thing out. And it doesn't need to tell the router or where RADVD is running that it's now on the network. It's completely stateless. You can pull that straight out of the examples, I think, in the wired DHCPD package. It's all pretty straightforward. This one here, the SLID, you can add that to the end of the prefix. So you'll be given a /56 or a /48 from your ISP. You can set that number to be whatever you want, and it will add that to the prefix and make your first subnet, which lets you break up your subnet even finer grained. So if you've been given a /56, you can break it up into a number of /64s and have a really complex network behind you, instead of just the one subnet. But really, for most home stuff, that will be fine. Again, RADVD, we've been given, or we're handing out /64 subnets. You can put, this stuff here is optional. You can put your DNS server and your domain name in if you want. Again, the MTU is optional. I actually have mine set much, much lower than that. But really all you need is the send advert and the prefix, and RADVD will do its thing. You don't even have to put in your prefix here anymore. You used to have to put in 202 : whatever is you've been allocated. RADVD will actually just pull that off the interface and work out what it should be advertising itself. So if your prefix changes because you're using 624 or 6RD, it will work that out and it'll re-advertise the new prefix for you. So that can stay as a static config. You don't have to change it as things change. So the awesomeness of IPv6 over PPP. You don't need anything to do with IPv4. You'll be given, you know, obviously when you connect, you'll be given an IPv4 address. You don't need to use it. You can run a purely, it's not a dual stack network, single stack network, and you don't need to touch v4 again. Because it's directly over PPP, you're not tunneling it inside anything else, minimum overhead. We've discussed that already. You get a static prefix star if the ISP is nice to you. It's a lot more work for the ISP to set up. They need to run v6 to a lot more of their devices. Obviously, their BBAs or BRASs, so that where the PPP is terminated, needs v6. It's all just really complicated for them. They need to run a dual stack network. Not something we need to worry about, but there is only one ISP in Australia who's done it successfully so far, Internode. Telstra do a little bit for corporate stuff. Amcom will sell you a v6 connection as well. But for you and I, Internode's the way to go. You do need special support on your CPE or a Linux router that you can fiddle with. That's pretty easy to sort out. Okay, 6RD. This is what IONET's doing. I don't like it. I think it's lazy. The difference is, well, there's a lot of differences. The reason it's lazy is they can drop this thing here in, their 6RD router. It lives on a v4 address. It only needs minimal v6 connectivity into their border router and out to the internet. The rest of their infrastructure can all remain IPv4. So that's why this is why ISPs like it, because it's simple. They put one box in and they've delivered v6 to everyone. Not really. In Australia, you'd be hoping that there's one of these in every capital city so that you're not routing across to Sydney for your v6 traffic. Again, no guarantees that that'll happen. You're up to the will of the ISP. There's a lot more colours in this because our stack looks like this. We have our TCP UDP session on top, IPv6 packet wrapped in an IPv4 packet wrapped in a PPP packet wrapped in Ethernet. And you lose another 20 bytes of your packet size. Not such an issue.
So your MTU that you advertise via RADD internally needs to drop by another 20 bytes?
Correct. Yeah. Process, again, PPP brought up, you get a v4 address, your CPE creates a tunnel based on that v4 address. I suppose, yeah, I should probably explain how it works. The ISP will have allocated a v6 prefix for 6RD. And what happens when you connect, you're told what that prefix is, you take your IPv4 address, convert it to the next part of that prefix, and that's your subnet. So your v6 address is based on your v4 address. If your v4 address changes, your v6 address changes. Not only that, your whole prefix changes and you've got to re-IP address your whole network. It's really, really nasty. It works okay if you've got a static IP. Who can afford those? It's really lazy and nasty, but it will get you onto the v6 network. Nick asked how it differs from 6 to 4. 6 to 4 does the same thing, takes your v4 address, adds it to a prefix, comes up with your network address. 6RD has a dedicated router that lives at the ISP, which will be the other endpoint for the tunnel. 6 to 4, you're relying on a benevolent provider to have an Anycast router somewhere out on the internet. I'll sort of, it's highlighted in the diagram further on, but sort of 6 to 4 works just for your ISP. 6RD works just for your ISP. 6 to 4 will work for anyone.
So
Both. Oh, which? That's v6. Green is v6. So presumably, yes, it will have IPv4 as well for all its customers who aren't playing in v6. But in terms of getting to the internet on v6, you're on dual stack over here, and it becomes native v6 only between the R6D router and the border router and the internet.
So why is it easier?
Well, because you only need to get connectivity to one device. You don't need to connect it to all of your BBAs.
And the IPv4 that you're using between the customer premise equipment and your 6RD router, that could be RFC 1918 reserved address space, effectively. Yes. It's just a transport layer. It doesn't need to be globally visible if you're going to rely on IPv6 for everything.
Correct, yeah. So that will give you a globally routable v6 address that's based on a local subnet range.
So optionally, you could keep v4 if you wanted to as a public IPv4, or you could move to a CG NAT kind of environment where your v4 is either natted or just walled off.
Yep.
Okay.
So I guess, yeah, that's probably another reason why ISPs would like it, because they don't have to deploy as much v4 public address space. They can reuse their private, or not reuse, they can use private address space, save on that allocation, and still give people, you know, IPv6 connectivity for what it's worth. Okay, as I said, IONET's playing with this at the moment. This is their v6 solution. I'm not aware of anyone else doing it in Australia. It's pretty popular in the States, probably going gangbusters in China. Actually, they've probably just got native v6. They're streets ahead of us. You need a bit of a script to create the tunnel, and you need an RA-DVD configuration. So it's pretty simple on the user's behalf. Script looks like that. Create the tunnel device. Give it a prefix. No, give it a prefix. Give your Ethernet card a prefix. Set the link up and add a default route, and you're away. That's the really messy way to do it. The really simple way to do it is you go to this address and you get that script, and it all just works. Yeah. Yeah, all right. The RA-DVD config looks similar, except we add in this one here. This says we will advertise every 15 seconds. We need to do that because if our v4 address changes, our prefix changes, and our network will break. So if you've left it at the default 600 seconds, and you reconnect to the internet and you get a different IPv4 address, your network will be down for the next 5 minutes until RA-DVD re-advertises the prefix and everything learns what their new address is. So you've got to pretty much flood your network just to keep everything current, unless you're on a phenomenally stable connection. And your MTU is a little bit smaller because you've got to squeeze that v4 header in as well. As I said, simple for the ISP. They don't have to invest a lot in infrastructure or setup in general. They don't need to be able to authenticate users when they connect to v6. They only need to be able to authenticate the v4 PPP session. They can bolt it in on top. Already covered that. Really, it's this. When I played with this on a friend's connection, I rebooted the router a few times, went back and had a look at my machine, and I had half a dozen different prefixes assigned because every time I connected, I got a new address, new prefix, and I hadn't reduced that advertised period. If you reduce the advertised period, it's reasonably good. You'll lose your connection for 15 seconds and it comes back and it's all good. Yep, covered all that. Increased latency, a little bit because you've got to hop through that 6RD router before you continue on. In practice, you don't really notice it, particularly if they've got quite good IPv6 connectivity and nobody else is using it. You'll get good bandwidth. More of a problem with 6 to 4. Your next best option is a tunnel. This is for people who aren't on Internode and aren't with IINet, which no one here, right? Didn't think so. Again, lots of colours here because we've got IPv6 wrapped in IPv4 over PPP. We drop our PPP session here, and it's just v6 in v4 to some tunnel router out on the internet. So this isn't covered, this isn't something provided by the ISP. You're getting this from a third party. Hopefully in Australia, more likely in the Europe or the States. Same packet layout as 6 to 4, same byte sizes. Go back. Similar sort of setup process, except you have this GoGoC client. It negotiates the tunnel, so does your authentication, finds out what your prefix is, sets up the device, the tunnel device on your router. It's available for Linux, Windows, FreeBSD, everything. You can run it on an individual machine, or you can run it on your router and have it advertise a prefix for you. So it's quite flexible. I have it on my laptop at the moment, running over Telstra. It works really well.
The tunnel is to the US, does that mean you get a US address?
Yes. Yep.
Could be a good way to get around geo-blocking?
I guess so. It depends if... Oh, so the question was, if the tunnel's to the US, do you get a US address? And yeah, you would. Whether it would get around geo-blocking or not, it would depend if the content provider's providing their stuff on v6 or not. And you know, guys like Netflix and that sort of thing, as far as I'm aware, aren't. So, not going to work for you. You need an account, you need a client, you need RADVD. Accounts are easy to come by. As I said, AARNet do a really good service. I think it's based out of Sydney, but it's for non-production traffic. I may or may not be using it for production traffic. Freenet 6 used to have an endpoint in Sydney. It's disappeared about 6 months ago, hasn't really come back. No real intention of bringing it back. I'm not sure what's happening there. Hurricane Electric are another big one. I think they've got stuff in Europe and the States, nothing in Australia. Config file is really simple. It's quite long, but the only bits you need to change, username, password, server. That will, by default, be anonymous. You change it to any. If you're hosting on a router, change to a router. And your LAN's network card. That's it. Restart the client, you're away. Very simple. That's all pretty familiar now. Reduced MTU because we've got that v4 header in between v6 and PPP. As I said, this isn't provided by ISP, it's provided by a third party. So you can use the same client with, you know, your 3G dongle, go home, use it on your DSL, run it on VPS somewhere. Very flexible in that regard. And you'll get, if the same account will typically keep the same prefix. So if you're connecting from different connection types or different addresses, you'll still keep that same IPv6 prefix, which is quite nice. Can do just your laptop, whole network, very flexible, static prefix. This is for if you're ending up in the States or Europe. You know, you'll add a good 100, 150 milliseconds to your connection or more. The tunnel providers will probably have limits on how much traffic you can push across it, particularly someone like IARNet, who's, you know, non-production. They would get grumpy if you started pulling large amounts of traffic across it. If you buy from IPv6 now, you'll get a data plan and you can go for your life. I don't remember why I put additional cost in there. Oh yes, if you buy from IPv6 now, you've got to pay for your internet connection and your tunnel. So it's an extra $20 a month on top of whatever you're paying. It's up to you whether it's worth it. 6 to 4 we sort of discussed already. This is the same, that's the same as your 6RD router, but it uses a common prefix. So they've set aside 202 colon as your 6 to 4 prefix. So you go 202 colon, your IPv4 address, colon, and then your subnet, you're away. The Anycast router has a common IPv4 address, which escapes me, 192 dot something, 192? There's multiples of these around the internet, and BGP will just work out where your closest one is and land you on it. The problem is we don't have any in Australia, so you'll end up in the States or Europe again, or maybe somewhere in the Asia Pacific. That's to get you land on that router if you're going to the rest of the IPv6 network. So anything that's not 2002, you'll go via that router. Anyone else who's on a 6 to 4 prefix, you can talk to directly, because you take 2002 plus the next bit will give you their IPv4 address, and you talk to them directly on their IPv4. It's kind of cool, bit problematic because as your address changes, your prefix changes, it gets a bit messy. Apple airports, early models of the Apple airport, would do this. And it was really nice. It made things like, what's called iTalk, Apple Talk, work beautifully because you didn't have to deal with NAT anymore. You know, your MacBook had an IPv6 address based on 6 to 4. Your friend's MacBook had one on their IPv6 address. And they could just talk. And, you know, RTP or your audio streams would work, your video streams would work. Beautiful. What they didn't appreciate, which I'll cover a little bit later, nothing has firewalls internally, right? Most devices don't bother with firewalls these days because they sit behind a NAT. So Apple, you know, sets up this airport with a 6 to 4 gateway and access to the rest of the IPv6 network or internet, and didn't do anything to protect people coming in. So it got disabled. I don't think it's available as a feature anymore. It's a bit of a shame, but it worked quite well when it worked, aside from the huge security implications. But, you know, who needs security? Okay, packets look the same. Tunnels, 6 to 4 and 6RD all use this format. So you always lose that 20 bytes, but you do get flexibility. There's that 202 prefix. Pretty straight. It's, like I said, very similar to 6RD. 6RD is sort of an extension of 6 to 4, but just at an ISP level. 6 to 4 will work with anyone. Again, you can do it the manual way, or there are scripts and packages to do it for you. If you've got a static IP, Debian, this will work out of the box. You just put the appropriate stuff into your interfaces file and it just works. If you've got a dynamic IP, you have to first work out what your real world IP address is, then work out your subnet, add it to the interface, and away you go. Again, we reduce our advertised interval because our prefix could change at any moment, and we reduce our MTU. Rush slides. No involvement with the ISP at all, so they can go jump. No authentication. Sort of doesn't impact on v4, although it relies on it, and it's pretty simple to implement. As I said, it was just a one tunnel interface on your router, pretty straightforward. I really should have gone through these slides first. It's very crap because it relies on IPv4 and it's tied to your WAN address. That's all pretty much the same as all the other tunneled connections, reduced MTU, reduced bandwidth, increased latency because you'll be going to somewhere in the States, and we don't have any of these in Australia. If you want to set one up, Wire should set one up. They've got lots of v6 stuff. lots of money. Okay, so using one of these connections, we've now got a V6, or one of these methods, we've got a V6 connection. You're not actually going to make use of it until you edit this file here and uncomment. These normally have a hash in front of them. You need to uncomment all of these. And these pretty much set the priorities for which type of address you'll use given options. Without this, you'll always preference a v4. So if you have two different routes, not routes, I think if you get an A record and an AAA record, you'll always use the A record. Okay, uncomment these, and you'll prefer to use v6 instead of v4. You can explicitly use v6 without adjusting this, but for it to happen magically, so that when you go to facebook.com, you're going to them on v6, you need to uncomment that. Similarly, in Firefox, you need to tell it that actually you want to use IPv6. That's in the about :config. I'm sure you've all played with it and broken stuff. It's a nice add-on. That green came out horrible. It's not my fault. That's the color they chose. Nice add-on for Firefox called Show IP, and it'll tell you what address you're connecting to a website on. If you're coming up with lots of red IPv4 addresses, you're probably doing it wrong. This is obviously Google, and it just sits in the bottom corner of your Firefox browser and shows you how you're connecting. I find that there's a lot of websites now that I go to that surprise me that they're on IPv6. Like there's a couple of webcomics that, I don't know, the admin was clearly bored one day, and a couple of gotchas. Okay, this one had me going for about a week. It's a wireless bridge. IPv6 doesn't use ARP to work out your MAC address from your IPv6 address or vice versa. It all just magically happens. Probably because it uses the prefix and your MAC address as your hold address, right? The issue is 802.11 doesn't allow a client to have more than one MAC address. So if you're doing this sort of arrangement where you've got an access point and a wireless client and then an Ethernet connection to your computer, or worse, multiple computers, they'll all appear to be coming from the MAC address of that wireless client, not the MAC address of the computer. So they'll assign themselves a v6 address based on their MAC address, but it won't ever make it across that link there because it does NAT. There's that word again. And it does break them badly. Fix is to use WDS, or wireless distribution. That will allow you to have any number of MAC addresses behind that. This isn't actually a client anymore. It becomes another wireless access point. You need to be aware of the implications for your wireless bandwidth with WDS because it can halve. Because obviously, if you think you're connecting to this access point with your laptop, but you're actually connecting to this one, it's got to go, over wireless. Wireless in, wireless out, you're halving that. If you've got multiple access points or it's strung together, it could impact your performance. In reality, it's not too bad, works quite well, and it makes a lot of other things like multicast DNS and stuff work much better. So yeah, go get rid of all your wireless clients and implement WDS. It's much better. And when you finally come to implement v6, you won't get caught out like I did. Yeah, this is probably the most painful thing about IPv6. You sort of get used to being able to log into your router with 192.168.1.254 or know that your printer is .10 or, they're easy to remember. There's no way you will ever remember your printer's address. I guarantee it. So you need to have DNS. This becomes a problem because most things don't do stateful address allocation on v6. You're just allocated a prefix, you choose your own address, go for it. How that address relates to your host name isn't recorded anywhere. You can use the wonderful world of multicast DNS. That works quite well if you're on the local network. So I'm on my laptop, I'm logged into my router, I can go router.local and it will translate it to the IPv6 address. It just works. If you're elsewhere on the internet and you want to log into the router, you either need to remember the IPv6 address or have a host name that's associated with it. Not so bad for things like routers, servers, where that's pretty static. If you want to be able to log into your laptop remotely, your laptop's host name will need to be registered against your domain name, and it can get a bit trickier. That's where you use dynamic zones. This was has been around a long time for IPv4. It's pretty much a system whereby DHCPD can update your bind zones with your forward and reverse lookups. It's quite nice, well worth taking the time to set it up. Don't be lazy and just use DNS mask, which does it all for you, because it doesn't support IPv6. Take the time, work out how to do it with bind and DHCPD. It's worth it. Or you could probably use Windows, but I don't know, I haven't done that. Corporates. So to do dynamic zones, like I said, you need ISC DHCP server. This is this package for Debian, package for Ubuntu. You need bind 9 and some configuration, which I'm not going to cover here because it is complex and painful, and there'll always be one semicolon you miss and it won't work. Maybe we'll cover it in another talk. The trick is ISC DHCPD will assume that you want it to hand out addresses for v4. All the configuration is structured around that. The package is built around assuming it's v4, and it assumes it's the only one running. You can make it hand out stuff for v6 by handing it the -6 flag, but then you can't have one handing out v4 addresses. The real solution, which I have to implement at some stage, is 2 packages, one for v4, one for v6, with separate leases files for your v4 addresses and your v6 addresses, separate PID files, separate config files. It's pretty easy to do yourself. Just copy everything, put a -6 at the end, edit your init script. Or I might package it up and James can sign it. Okay, we talked a little bit about firewalls already. NAT gives us this warm, fuzzy feeling of security because we're cocooned inside our private IP space and the internet can't get to us. There's a couple of hacks around that. Recently, UPnP was proven to be pretty broken in that from out of the internet, you could trigger a router to open a tunnel through to your v4. It's all very scary. The real issue is, as I mentioned before, nothing has firewalls. So your router will have a firewall, maybe, if you're lucky, probably. Your printer, your file server, it's unlikely to have a firewall. Who can really be bothered setting up IP tables on their laptop? I know I can't. So that works okay for v4 because we're behind a NAT. v6, well, yeah, so because no one's done it for v4, they've really sort of just bolted v6 onto the existing product, not updated the firewall settings or anything like that. Everything's open. As a minimum, to give yourself peace of mind, you should do that. So here we're saying everything that's already allowed, you would have seen this for v4 already, right? Everything that's already allowed or related to something that's allowed, we should let through the forward. Everything else can drop dead. And that will at least stop at the border router anyone coming in from the internet to your local address. Even more important, if you've gone to the trouble of setting up DHCPD and bind to update your host names, and suddenly your laptop's host name is available in your zone record and people can just log into it. Yeah, so chuck that on your border router, everything will be fine. Any questions? So who's with IONET here? Internode? Oh yeah, Westnet. I count Westnet as 2 guys with Internode. Are you running V6 at home? You slackers. You know it's enabled by default now, right? Do you have their router? Like, did you get the router that they supplied with it? Okay.
I'm using a WRT for PL, but I haven't set it up yet.
Running OpenWRT? Or
DDWRT.
see, DDWRT doesn't have particularly good V6 address, V6 support. It can depend on whether you've got the small image or the full-blown image, I think. On some of the routers, because they got less memory, they don't include it. You might be able to get it going without too much hassle. But you've probably got the easiest connection to try and set up out of all the options, because all you need to do is configure PPVD to request your V6 address, and away you go. So all you IONET guys should probably have a look at who's running the IONET router, like the Bob Light or no one. Just
I inherited it when flatmate moved in.
okay. So there's a they have a firmware on their FTP server which will enable V6, and it will all just work for you magically. I don't know if the original Belkin. They probably. I think it was only the Bob and the Bob Light supported it.
No, my Cisco died, so I had to revert.
The really frustrating thing is that guys like Netgear and D-Link are putting on a big push to support IPv6, and all their routers are coming up as IPv6 certified, except for their ADSL routers for some bizarre reason. So everything that's got an Ethernet port at one end and then multiple Ethernet ports at the other, yeah, we'll support V6 on that, no worries. Anything that would be useful, no.
But surely ADSL routers are, 6 to 12 months away from being end of life. How is the NBN going to affect this?
Well, NBN, because it's layer 2, right, it's still up to the ISP to implement. So if you're on an NBN connection, there's no requirement, I think.
So effectively, you're just going to have a router on premise to one of the ports in the back of the NBN CPE. And so long as your router can support IP6, and that could be a Linux box, it could be a dedicated microcomputer of some sort.
Yes.
Then yes, you could do any of these.
Yeah, and if you could do yourself some favors and get yourself an Internode NBN connection, and it will be amazing. You can get an INET one, it'll be less amazing, or you could get a tunnel, and it'll all just, it's okay as well. But yeah, NBN, you're right. No, sorry, you're wrong. It's not going to be 12 months, right? My suburb isn't even on the 3-year plan.
Yeah, but I don't live where you live.
So yes, when you get, I mean, there's other ways around it as well for ADSL. You could obviously get an ADSL modem with DSL on one side and Ethernet on the other, and then use one of Netgear or D-Link's amazing V6 routers, and it will be fine as well. A lot of them do support, well, not a lot. There's a few that support 6ID. Most support 6 to 4 tunnels. Most will support DHCP over PPP. Bit of a mixed bag. But yeah, if you want to go the Slack route and just buy hardware and throw at it, you can do that. Or you can get yourself a Cisco. Cisco, this is easy. It's a few lines of config and for any of these solutions. So if you've got lots of money, buy yourself whatever the equivalent of the 800 series DSL router, and it'll all just work. Yeah, yeah.
If addresses are globally routable, isn't that kind of scary in terms of security and being able?
That's why you need that firewall on your border router.
Yeah, but it's still people can track you, like you can be tracked based on your address.
Yeah. Okay. Yes. There's an anonymizing, pseudo-anonymizing function where instead of sending, you can allocate, or you can have your device allocate itself a second address, which isn't based on its MAC address, and you can make connections from that. So it's not directly tied to your MAC address, unlike your normal IPv6 address. And then it will just appear to be coming from your internet connection, or a computer on that internet connection, rather than a specific identifiable machine on that internet connection. Yeah. So I guess something to be aware of in that if you're browsing sites from your laptop that's on V6, you can be directly traced, sort of.
I guess that also leaks a lot of other information because the MAC address normally indicates the manufacturer of the PC that you're using, which can now be determined from your IPv6 address. So sites can delve a lot deeper into what hardware is out there on the internet. Potentially.
Yeah.
Or prioritize which ones they're going to break into first.
There's no absolute requirement to use the automatically assigned address.
But it's default, isn't it?
It's default, yeah.
Yeah.
But you can just as easily statically assign an address out of that subnet.
Mm.
The MAC address thing was just an easy way of getting stateless auto configuration. But yeah, you can manually assign. You could use DHCPD to hand out specific addresses based on the MAC address, but not directly related. So as in, you can give yourself :1, :2, :3, based on specific machine addresses. But they won't include the MAC address in the. Yeah.
Okay. Yeah. Yeah.
You can do interesting things as well, like mobile IP. So this is where you have a fixed subnet for your home connection, and your mobile device can be set up to use an address out of that subnet even when it's not connected to that network. And the way it works is it negotiates with your border router to say, hey, I'm over here now on this IPv6 address. I'm going to send requests out and you need to forward them to me. So you'll send a request out from your home subnet, but over here, and the replies will come back to your home connection, then bounce across. So you can keep the same IP address regardless of which internet connection you're using, which is sort of interesting. It has interesting implications for VoIP and.
Because you can run multiple addresses, that means you can have an address in the local IP you're connected to, plus your mobile address. So if the traffic to your home LAN or office is coming, that traffic will use that address and go there. Hopefully, any traffic to browse the internet.
Yeah. The actual implementation of that is a bit, bit more interesting because you'd need some way of having, your applications decide which addresses they're going to use. I have seen a demonstration of it streaming or downloading a file, a large file using wget, and the guy unplugged his Ethernet cable, started up his 3G connection, and the download paused and continued, even though he'd gone from, presumably his home or his work DSL connection to a mobile. His computer's IP address hadn't changed. It wasn't that wget had dropped the request and continued it. It was the same request. It was the same stream of data. It was just coming in over his 3G connection now. So, that's interesting. It's not very popular yet. There's not a lot of implementations for it, but it could be quite big in the future.
You've actually just answered most of my question, but what if, similar situation, but what if you've actually got two simultaneous interfaces, so like a Wi-Fi connection and an Ethernet connection, or say you've got a connection to the internet via your router and then another one via a mobile broadband dongle that are active at the same time?
Yep. So that's handled the same way that V4 is handled at the moment, where each interface type gets a different metric. So your Ethernet connection will have a lower metric than your Wi-Fi connection, which will have a lower metric than your broadband connection, or mobile broadband. So if you've got multiple routes to the same address or the same destination, you'll choose the lower metric path.
Okay, so it will be the same address, potentially.
Well, no, you would presumably have different addresses on each of those interfaces, and they might be on different subnets as well, depending on what network they're connected to. With mobile IPv6, you can sort of get around that by telling your home network, hey, I'm over here now, and it will use the the interface address and the network you're connected to get to your mobile address.
Yeah.
But the metric is still what determines which interface you use to get to any given route. Yeah.
Is there a key for that, or how does it authenticate that this random device off the internet now wants to pretend to be local? Mobile IP.
Yeah, so the typical way of doing it is something like IPsec. I've seen an implementation using OpenVPN as well. But yeah, you would need to authenticate that traffic somehow so that James can't steal Nick's traffic. But yeah, that's you're right in that sense.
So if you could fix, say, 3 things with the current state of IPv6 in the world, what 3 things would you choose to fix and in what order?
More hardware VoIP phones which support IPv6.
Yep.
Because even if you're using a 6-to-4 connection, right? You haven't bought a tunnel, you're not with a sensible ISP, all you're using is a nasty hack of 6-to-4, they will still just work. You're not mucking around with having media proxies and using
Stun
symmetric
servers
NACs.
and things like that.
Yeah.
So which handsets, which hand phones currently support IPv6?
Probably Cisco.
Yeah, probably, right.
No, I doubt it. Because Bob's using IONET's internal VoIP server. Will only ever use IONET's internal VoIP service, and that's all on v4. So they've got no real need to support v6 yet. They could even do something nasty like split the VoIP stuff off onto private address space on a different virtual circuit on your DSL, and just run it all on private IP. So yeah. Bob is unlikely to support it. But yeah, that would probably be number 1. Number 2. I don't know if it's really that important. The reason I got into v6 in the first place is when I was setting up my first web server 15 years ago. And I set up SSL, and I was really proud, happy with myself. And then I went to set up another domain on the same server using SSL, generated a certificate and that sort of thing, and then ran into the problem where you can only use one SSL certificate per listening socket, right? Because SSL expects you to already be talking SSL by the time you connect. There's no clear negotiation like there is in TLS, right? Your first character that you send is part of an SSL negotiation, and it's assumed that you're connecting, that the certificate that it's going to use to authenticate the connection matches the host name that you've connected to. So you can only have one certificate, one host name. I thought that was a bit of a hassle. I wanted to host lots of domains and lots of certificates. I didn't want to run them on port 81, 82, 83. I wanted to keep it all consistent. And I thought, how can I get more addresses without having to pay for them? v6 is the answer. So it's probably not that important because, firstly, if you're clever, you can sort of get around that. Or if you're rich, you can just buy a fairly wide-ranging SSL certificate. Or TLS is becoming more popular now. Most web servers support it. Most web browsers support it. No one's really using it for that yet, to be able to negotiate your host name and your certificate. Or, sorry, negotiate the certificate based on the host name, rather than just assuming that you're connecting to the... But yeah, more v6 availability would allow sort of enthusiastic amateurs like myself to host a wider range of SSL stuff.
But surely the adoption then of Start TLS on HTTPS connections alleviates the need to have a separate IP address port tuple for it, which is kind of like, well, NAT alleviates the need to move to IPv6. So we've got all of these stopgap measures which are either already here or almost matured enough that it keeps delaying us to the horizon again and again and again of actually just switching over to IPv6 natively for everything. Yep.
And what are we running at? 2% of the world's internet traffic is v6 at the moment. Hasn't really grown much. Even
what's going to be the thing that makes that change the most? What's going to make that 2% become 4%?
Last year I would have said Facebook, but Facebook's on it now, as is YouTube, and
Mhm.
it still hasn't really taken off. I think we need better uptake by the ISPs now. We've got the content, we've got the services available on it. It really needs the ISPs to get behind and start providing more options.
Mm.
Even then, as a home user, why would you bother when you can still get to Facebook? Even if you're behind 4 layers of NAT, you're still going to be able to get to Facebook. So, I don't know, sort of in the way that the NBN, is always touted as being the infrastructure to provide for things we haven't even thought of yet. V6 will be a very similar thing.
Mm.
It's the infrastructure, it's the building blocks to deliver technology that we haven't come across yet, and possibly can't develop at the moment because of these stopgap measures like NAT.
Mm.
So, yeah, when I think about how awesome it would be if everything was V6 and all the problems that would, just disappear, it's amazing, but not going to happen anytime soon, I guess. I really sold it to you there. It's kind of cool if you've got a V6 home network or a V6 work network and V6 on your laptop. It is nice to be able to hop directly onto a machine or print directly to your printer or something from wherever you are. That's sort of convenient. You can do it now with a suitably set up VPN, but it would be really cool if you didn't need any of that infrastructure. If whatever internet connection you plugged into, you know that you'll be able to route straight to your fridge or whatever.
So I remember we had a talk about nearly 2 years ago now when Kyle Girardi from Electronics out in Frio talked about how they had an incident where somebody started up IPv6 on a workstation somewhere and tunneled somewhere. Any other further advice from that of what to do if you happen to be an administrator of an enterprise network and what you should be looking at now? How could you be detecting this kind of thing and obviously installing the correct firewalls and IPv6 and watching out for tunnels? And
well, tunnels are sort of easy because that should be taken care of by your enterprise firewall, somewhere around your border router. So you just block all protocol 41, which is IPv6 inside IPv4, right? And that'll prevent those sort of tunnels. I don't know of too many places that have rolled out V6 all the way to the workstation, and consequently I'm not aware of any sort of unique and interesting security implications involved therein. There probably are all sorts of really weird stuff. But I sort of look at it that it will really just force people to do security properly. So at the moment we all live in this nice world where you're behind a NAT and it's all protected and there's the idea that you've got quite good security. My take on... Yeah, so that's right. Some things that should work don't, because you've got that firewall or that NAT in the way. And I guess the current methodology is allow most things out from inside the corporate network, don't allow anything in. That would still work under V6, that sort of methodology, allow most things out, don't allow much in. My take on corporate network security is that you should have available on your building an Ethernet port on the outside of the building which plugs straight into your core switch and hands out DHCP. And anyone should be able to walk along and plug in and not get anywhere, right? You should provide open access to your network and it should be suitably secured at the application and the server level such that you can let anyone onto your network and they're not going to be able to do anything. If you're at that level, V6 should hold no real worries for you.
Because you're always going to have guests and random contractors anyway.
Guests, wireless network issues, yeah, and then, it's just, if you're at that level where you can allow anyone onto your network and be confident that there's no security implications there, then why not extend your network out onto the internet and allow people to work from home and use iPads and, instead of firewalling ourselves off, not firewalling, it's a bad word, insulating ourselves into this single island and everything on the island is sort of trusted and safe and secure and everything outside the island is bad and scary. I have the opinion that if you're a bit more dedicated with your individual application and service security, then you can be a bit more lax with your edge or your border security without really impacting things. I don't know. James is giving me a really skeptical look. No. No, we don't. Not for stuff I work on. In fact, we're really, really nasty in that we run public IP space in a private way on our networks. So when Motorola deploys a APCO 25 radio network, it looks exactly the same. So Melbourne's MMR network looks exactly the same as Adelaide's government radio network, looks the same as WAPOL's network. Exactly the same IP addresses for all the devices, same devices plug into the same switch ports. It's not connected to anything else. So the radio network stays entirely cut off from the rest of the world. And as such, we can use whatever the hell we want as far as address spaces.
So why not use IPv6 in that environment and still have it cut off from the rest of the world with your own allocation of IPv6?
Probably the same reason that IPv6 isn't used very much anywhere else, just legacy. We're using v4, we've used v4 for a long time and it seems to work reasonably well.
So legacy of the hardware manufacturer that's
Correct.
making the... And who's that hardware manufacturer?
That would be us.
Right.
Well, yeah. We're using routers.
Right.
Motorola bought 3Com about, 10 years ago?
Oh, that could move.
Yeah, it was an excellent move.
Where are they now, 3Com?
Well, I think we fired all their development staff and have been using the same hardware ever since.
Right. Didn't they go out of business?
Who? HP or
Well,
3Com?
HP bought 3Com, you're right, yes.
They probably... we're certainly using 3Com routers rebranded as Motorola.
Yeah.
All of our gear supports, like I've looked through the config and it will support v6, but because we're playing in the public safety space and everything needs to be super secure and super reliable and stable, and they don't do big changes. So v6 will probably come, it'll probably be mandated by some US government contract. You must support or you must run IPv6, and there'll be a huge push to implement it, but it's not coming anytime soon for us.
So my understanding of the US governments is that they are mandated to require any service to be delivered over IPv6 star. That little star in the corner there is, unless you write yourself a note to get out of school. In which case, every year what they do is they write themselves a little note saying, we don't need it in 2012, we don't need it in 2013, we don't need it. And therefore, although it's officially mandated and required, it's not really happened that much.
Yeah. We would be writing ourselves all sorts of notes.
Yeah.
RF networks use ISIS as well, don't they? The routing protocol.
Yes, not ours.
Oh, okay.
We've got like the stack for 6 to 4 there is nothing compared to the network stack that connects a site to the core network in Motorola. It's amazing. It's about 7 layers deep. But we use OSPF and sort of fairly standard stuff really.
Okay.
Again, we use stuff that's tried and tested, and don't make big changes just because something new's come along.
Any other questions before we wrap up? Yes?
Just from what you were saying about security on corporate networks and things like that, how would you imagine your philosophy applying to a small business?
I would move everything into the cloud and let people work from home. Right? So if your email server is set up such that people can connect to it securely from out on the internet, then all you need is an internet connection. It's like, yeah, there shouldn't be, all your services should still be delivered in such a way that it doesn't matter whether you're accessing it from the office network or from your laptop or from your bedroom. You have the same level of access, same level of security. And then once you're at that step, your office network just becomes an internet connection. It's just a DSL router in the corner. Everyone plugs into, gets an address, and accesses their stuff. So yeah, move it all into cloud.
So you're saying if, for example, your email server is accessible from the internet, why bother having it locally? Why not just have it on the internet?
Yeah.
Works at Gmail, works at Hotmail.
Yeah. Even stupid Office 365 works reasonably well, unless you're on Telstra. But yeah, if you're providing, well, turn it the other way. If you're providing access to stuff on the internet, why do you need VPNs and a corporate network? You don't. You just need an internet connection. You can do it from a net cafe. So you would still have infrastructure surrounding your mail servers and everything else, like a DMZ and a firewall and that sort of stuff, to make it secure. But it should have the same level of security from the internet as it does from the local network. Yeah, there should be no difference, in Adrian's humble opinion.
That would be if you're running IPv6.
Well, yeah, IPsec could be part of that makeup. So you could mandate IPsec from your client to your server or an edge point before the server. And then if you're accessing it from the local network, you do IPsec. If you're accessing it from the internet, you do IPsec. It's all the same.
And use IPsec to authenticate each.
Yeah, authenticate and secure. Yeah, that's right. You can just as easily get away with using SSL TLS to do the same thing, right? It's just at a higher level than IPsec operates. But if you're providing a secure connection between your user and your service, the underlying infrastructure in between shouldn't really matter.
So you just move it higher up the stack in that case.
Yeah.
And that would be using client certificates as well, mandating certificates on each end.
Could do if that is deemed to be a yeah, that would all be sort of, depends on your level of paranoia. But I mean, when you're in the Amazon office, do you still have to use two-factor authentication?
Here in Perth, yes.
Yeah. See, so
For network access to the corporate network.
if you're mandating that in your internal network, there's no reason why you can't do the same thing out on the internet.
And the big question I always have whenever I hear anything about IPv6 is when you're on a large corporate network with multiple ISPs around the world, it's just how you manage your address base and what addresses do you use, because theoretically you may be potentially getting either a set of addresses from each ISP.
So that's the same problem that you have with v4, and that is you get yourself an autonomous system number and play BGP with the rest of the world. So
But that potentially then gets pretty interesting in terms of your border routers, then, doesn't it?
Oh, sure, but I mean, that's right.
But the IPv4, big corporations, all they do is they just run a 1918 address internally and make it private.
I see what you're saying.
Proxies on the edge.
Well, you could. Yeah, that model wouldn't work as well. I mean, there's some crazy NAT stuff you can do with v6 that they've sort of hacked up recently. Yeah, we're trying to get away from NAT. Why would you bother? Yeah, so use, what are they called? Serve records, right? We haven't made use of those very much. We should probably get into that. So that you have a hierarchy of servers that you can attempt. So if you're trying to hit your mail server, or mail server is a bad example, if you're trying to hit your proxy, yeah, web server, whatever else, SIP server, you look up the serve record and it'll give you a list of possible servers and their A records or their quad A records that you can attempt to connect to, and an order in which you should connect to those. So you'd have some over on that internet connection and some over on that connection. and your client looks up, gets this list of servers and just tries them in order. And if that internet connection is down, it'll sort of miss the first couple and land on that one instead. So you're moving that failover redundancy type thing, again, further up the stack, away from your layer 2, layer 3 stuff. So it would be doable. As far as your outgoing connections go, there's no reason why you couldn't give, because IP space is cheap, right, in v6. You could just give all your clients or your internal machines 2 addresses. And I don't know how it would work. Presumably it would try and establish a connection from the first address or the address with the lowest metric, find that that gateway is down, fail the connection, try its next. So there might be a performance hit in terms of delay or latency for establishing connections in that regard. But there's no reason why, yeah, you can't have multiple addresses per machine. Well, your edge firewalls will only deal with subnets associated with that connection. So you would have, you could conceivably have the same firewall script or config or whatever you want to have, based on your device, on each edge connection, and just change the prefix that it handles at the top, and that trickles down to the rest of the config. So, you'll only ever be wanting to allow connections from the subnet allocated to you by ISP A through ISP A. And that's all you need to worry about for that connection. And then ISP B, the subnet from ISP B would be through that connection. So your firewalls should be still fairly, shouldn't need to take into account that you've got 2 subnets.
Cool. Lovely. Alrighty, so let's wrap it up there. Ladies and gentlemen, please thank Adrian. So just a couple of things I wanted to go through with Plug stuff. Obviously a reminder, Plug membership is $20 a year, $10 for concession. If you're not a member, please see Peter at the front here, our secretary, who I have spotlighted only because I thought we may as well do something. Not at all. Other news, end of this month should be the quiz night. Who here has not been to the quiz night before? Excellent. You've been. I know you've been. Didn't you win one year? No? I thought you had. Okay. So the quiz night is going to be the last Monday of the month, which I can't remember the date. Anyone know what the last Monday of March is? Why not? That'll do. At the Moon and Sixpence. We have 2 prizes so far, but that's nowhere near enough. And I need some volunteers of people who'd like to find some prizes that we can use to give away at the quiz night. They can be anything at all, but yeah, if desperately need it. I don't have time myself to go and find more prizes. I don't know if anybody else has or has not. No one else has come to me. Please, if you've got a prize or something you can organise. You got some prizes? Brilliant. Awesome. Next month's talk. Does anyone from committee know what next month's talk is? Excellent. We're going to work that one out. Any other Plug news that I can't think of right now? Meetup page is up. So thank you to Paul for organising Meetup. Yes? Certainly. How do you know when your Plug membership expires? Well, you should get an email. There was a period recently where this was not happening, and then it got fixed, and lots of people got lots of emails in a short space of about 24 hours. This makes an interesting conundrum for our annual membership fees that come in. They're all now coming in at one point in time. But yeah, obviously the membership, Plug is non-profit. That membership money goes into things like buying some of the prizes that we've bought, operating the Plug PO box that we've got as a registered organisation, and also anything else that comes up from time to time. We've been doing a fair bit of stuff on the video team, so obviously we've got all the cameras set up again tonight. This was also done on the weekend for Startup Weekend that was held actually here again. And we've recorded and videoed pretty much every presentation for the last 2 years. Yeah? And this has been also a part of a wider plan that I've had, which is to get someone here, who I'm looking at right now, to run Linux Conf AU 2014 here in Perth. 2 people I can see. So for those of you that don't know what Linux Conf AU is, it's the National Linux and Open Source Conference, last held here in 2003. The last time this conference ran nationally was in January this year in Canberra. It moves from city to city each year, and we get a large number of very interesting speakers come to town. So in 2003, I can remember we had, obviously, Linus came to town. We had Rasmus, who wrote PHP. We had Alan Cox, who did a lot of the networking stuff. Obviously, Rusty is always a feature of the conference, given that he started the conference. Yeah, Tridge and Andrew Bartlett and Jeremy Allison have been, so some of the core Samba developers. A whole heap of interesting things. I've got to say some of my highlights more recently have been Tridge's talks on things like his homemade coffee roasting machine and his Find Joe stuff, which was the unmanned aerial vehicle, the UAV stuff that he's been working on, where he actually hacked up radio transmitters and improved the throughput of sort of ground-to-air transmissions by something like 85%. It's just super impressive. So anyway, this conference is... And the manufacturer started shipping his firmware by default. I mean, that's just testament to how clever the guy really is, and the rest of the people that he works with. So the conference is coming. Volunteers needed for all kinds of stuff. See Paul and see Luke, and express your interest to help out. When the conference itself does happen, there will be a lot of people needed. Obviously, videoing like this will be trying to happen for 4 simultaneous streams live if we can, plus things like just helping speakers get to rooms, helping people find accommodation, all kinds of stuff will happen. Packing bags, the standard conference kind of stuff. And even now, I mean, there's stuff that needs to happen now. So obviously, Luke's all over sponsorship stuff at the moment. So if you've got employers who'd be interested in making sure that their brand gets seen amongst the cream of the crop of Australia's development talent and open source talent, then get onto that. I think I've got on for long enough. Anything else I've forgotten, guys? No? In which case, thank you everyone for coming, and hopefully we'll see you again next month. Thank you.